Thank you for joining me in this meeting. We will continue talking about module number one, particle motion. I would like to remind you what we covered on the last week. The material in last week was talking about a particle moving in a straight line, which is called curvilinear motion. Rectilinear motion. So straight line means you have a position S, you have a velocity V, you have acceleration A. Your displacement or your position S will be given as a function of time. We can figure out the velocity by making differentiation for this position with respect to time. Or we can differentiate the velocity with respect to time to figure out the acceleration. And you keep it in your mind, if V or A or whatever are function of S, not function of time, we have another relationship saying V dV equal A ds. This relationship can be used if and only if the acceleration is a function of the position, not a function of time. Also, in the previous week, we learned sometimes your particle is moving in a curvilinear motion. Curvilinear motion means we have a path. No, this path is not a straight line. So we learned that at any position, you will have X and Y component for the position. X may be a function of time, Y is a function of time, or something else, whatever. So at any position, I will have Vx and Vy. At this position, I will have Ax and Ay, two components for the velocities, two components for the acceleration. The x component of the velocity equal x dot, y component y dot. X component of the acceleration, x double dot. Y component will be y double dot. Dot means first derivative with respect to time. This is if you have a curvilinear motion and you are talking about x and y component. Today, we still talking about curvilinear motion, but we will have another two components, not x and y. They are normal and tangential. To be very more specific, here is the curvilinear motion, and you have a point here. I am going to figure out what is the value of the velocity, which is tangent to the curve. And for the acceleration, I will have one tangent and one in the radial direction. That makes sense? This is the reason why it's called normal. I'm sorry, normal, not tangent, normal. In normal and tangential components. That makes sense? So the normal will be perpendicular to the tangent direction. So if you have a curve, if I'm giving you a curve looks like this one, and I'm asking you what is the direction of the velocity at this point, the direction of the velocity will be tangent. We have only one component, which is tangent. What are the two components of the acceleration? We will have one tangent and the second one perpendicular to this tangent, which is called an normal direction. You can watch the recorded videos for covering this material for the normal and the tangent component of the acceleration and one component for the velocity, which is tangent. To summarize these expressions, here you go. Your velocity, we will have only one value for the velocity, which is tangent, equal first derivative for the position with respect to time, S dot. That makes sense? For your acceleration, we will have two components. one tangent and one in the normal direction. The tangent equal first derivative of the velocity with respect to time, v dot. The normal component v squared divided by r. R sometimes it's radius. If you have a circular motion, your motion in a circle. In this case, rho will represent the radius of this circle. Or if you are moving in a curve, it's not a circle, this curve will have a function, f of x. Then your rho can be determined using this expression. Go back to the recorded videos, you can find many examples. Does that make sense? But after you get the tangent and the normal component of the acceleration, you can get the final value of the acceleration by taking a square root for the tangent component square plus the normal component square. Let's do one example on this part. We are talking about a curvilinear motion. This car at point A is moving in a circle. This circle is not a straight line. This circle is called curvilinear motion. And if you look to the problem, we are looking to determine the velocity and acceleration traveled at after 1/3 the way arrived. So let's start for this problem. So we are going to figure out the velocity and the acceleration after this car moved in this circular path 1/3 only. 1/3 of the total circumference of the circle. So first of all, your S distance, the distance that this car will travel equal 1/3 of the circumference of this circle. The circumference of this circle will be 2 by r. Keep in your mind your r, the radius of this circle is 300 meter. So the circumference or the distance the car will travel only will be 628.3 meters. So after this car moved a distance equals 628.3 meter, means at this position, what is the value of the velocity? What is the value of the acceleration? Does that make sense? This is the meaning of determine the magnitude of its velocity and acceleration when it has traveled 1/3 the way around. Does that make sense? So this is the first point. After a distance equal 628.3 meter, what is the value of the velocity and acceleration? It's given v dot. This expression is given here. V dot equal 0.06 t. What is the meaning of v dot? If you go back to the summary of this part of the chapter, v dot represented the tangent acceleration. So your tangent acceleration equal v dot equal 0.06 t. Does that make sense? And also keep in your mind, v dot means dv by dt. So I can say dv by dt equal 0.06 t. This expression can be written like this, dv equal 0.06 t dt. This is math. If you do integration for the left-hand side and the right-hand side, this one will start at the beginning from 5 to the final velocity v, I don't know. From the beginning at time equals 0 to the final time, I don't know. Hey, What you mean by 5? If you read your problem carefully, the car started from point A from the beginning. It has a velocity equal 5 meter per second. This is the initial velocity. This is the velocity at the beginning. So at the beginning, we have velocity equal 5. At the end, I don't know what is the velocity. At the beginning, we started from 0 time to t. So this integration will give you v from 5 to v equal 0.03 t square from 0 to t. You can simplify this expression. It will be v minus 5 equal 0.03 t square. So your final velocity will be 0.03 t square plus 5. So I found an equation as a function of time. I found an equation as a function of time for the velocity. This is one of the requirements. We are looking for the velocity. Does that make sense? We are looking for the velocity. If you do one more integration, because right now I do have your velocity equal 0.03 t square plus 5. Does that make sense? So your velocity also equal s dot. If you go back to the summary, your velocity equal to s dot. So s dot means ds by dt. So I can say ds by dt equal 0.03 t square plus 5. So ds equal 0.03 t square plus 5 time dt. If you do integration for the two sides, this integration from 0 at the beginning to s, this integration from the initial time 0 to t. So this one will be s from 0 to s. This one will be 0.01 t cube plus 5t from 0 to t. So the final conclusion, I can say your s, the final position as a function of time, will equal 0.01 t cube plus 5t. That makes sense? That makes sense? So keep in your mind, we are going to figure out the velocity and the acceleration when you travel distance s equals 628.3. If you put here this value for s, 628.3, this equation will have only one unknown, which is the time. So I can figure out the time when the car traveled this distance. So the time will equal 35.6 seconds. So I can say we need to figure out what is the velocity and the acceleration when the time became 35.6 seconds. That makes sense? This problem now became very easy because I know the velocity already equal 0.03 t square plus 5. Is it correct? So I can say my velocity will equal 0.03 time t square, which is 35.6 square plus 5. So the velocity will become 43 meter per second. Is it correct? And keep in your mind, it's originally given the tangent component of the velocity, which is v dot. It's already given 0.06 t. So your tangent component of the velocity equal 0.06 t. Now you have t, 35.6. So the tangent component of the acceleration will equal 2.1 meter per second square. Keep in your mind your normal component of the acceleration. If you go back to the summary, the normal component of the acceleration equal v square divided by rho. Since your motion in a circular path, the value of rho will be equal the radius, which is 300 meter. So v square divided by rho, your velocity equal 43 square divided by rho 300 meter. So the normal component will be 6.2 meter per second square. Once you get the tangent component and the normal component of the acceleration, your final acceleration will be square root for the tangent 1 square plus the normal 1 square equal 6.5 meter per second square. Now I figured out the velocity and the acceleration for this car when it traveled 1/3 of this circular path, or when this car traveled a time 35.6 seconds. These are the values of the velocity and the value of the acceleration. If you have any question, just let me know. Anybody has any question? Okay. Instead of having tangent direction and normal direction, instead of that, we will have another component which is called cylindrical component, which is called R and theta. R and theta. So if you imagine we have this curve linear motion. We have a particle at this position. I can figure out the position of this particle using distance R and the angle theta. These two components are called cylindrical components. If you go to the course summary, we have for the velocity, we will have two components of the velocity. The one is called VR, the second one called V theta. VR, which is called radial component, and the theta transverse component. So don't be confused. In the cylindrical component of the velocity and the acceleration, for the velocity, we will have a radial component equal R dot. For the transverse component, we will have a value called R theta dot. For the acceleration, we will have two components, the radial component and the transverse component, ER and E theta. R double dot minus R theta dot square, R theta double dot plus 2R dot theta dot. Once you get the two components for the velocity and the acceleration, I can write the final velocity equal square root for the radial component square plus the tangent component square. I'm sorry, this is velocity. And the final acceleration equal square root for the radial component square plus the transverse component square. That makes sense? But keep in your mind what you mean by theta dot, theta double dot. Theta will be given most of the time. Theta dot is the first derivative of the theta with respect to time. Theta double dot, second derivative of theta with respect to time. R will be given as a function of time. R dot will be first derivative of R with respect to time. R double dot will be second derivative of R with respect to time. So if we are talking about radial and the transverse component, we need to have r theta, r dot, r double dot, theta double dot. Using these values, I can set up the components for the velocity, the component for the accelerations, and then find my values. That makes sense? So more detail, more solved examples, you can find them during the week in the recorded videos, but let me solve two problems on this part. I have a particle moving along circular path. So we have a circular path with a radius equal 4 inch. So far, I'm not sure what is exactly in this problem. And here is the particle, such that its position as a function of time is given by theta. This is the start point. Since the position is given by theta, that means we are in these two components, transverse theta and the radial r directions. That makes sense? So your theta is given cosine 2t. By the way, for your information, I can find out theta dot equal the differentiation of cosine is negative sine 2t. Differentiation of the term inside cosine will be 2. One more differentiation, theta double dot equal negative sine, differentiation of sine will be cosine 2t. Differentiation of the term inside sine will be 2, beside 2 will be have 4. So this is the second derivative of theta with respect to time. That makes sense? So this is the first part. Based on the given information for theta, keep in your mind, we need to determine the magnitude of the acceleration of the particle. What is the value of acceleration A when theta became 30? So when theta equals 30, let me finish this first. Since your radius is given by 4 inch, this 4 inch is a constant value. It's not given as a function of time, because at any time after 1 second, 2 second, 10 second, the radius will remain the same radius, 4 inch. So if you differentiate this this radius with respect to time will give you 0. One more differentiation will give you 0 also. So now I do have values or expressions for r dot, r double dot, theta dot, theta double dot. Keep in your mind, to finish up any problem in this part, you have to put your hand on these values. That makes sense? But we did it, we have expressions for theta, theta dot, theta double dot, but what are the values? Okay, this is the point. We are looking for the acceleration when theta became 30 degree. Does that make sense? Keep in your mind, in this part of the problem or of this part of the module, we are using radian, not degree. So please, in your calculator, convert your calculator from degree to radian. So your theta will equal 30 times pi divided by 180 means pi divided by 6. Go ahead and put theta, because we know theta equal cosine 2t. Go ahead and put theta equal pi divided by 6 equal cosine 2t. The only unknown in this expression is the time t. Your time t will equal 0.51 second. So the problem asked to figure out the acceleration when the theta equal 30. I can say what is the acceleration when the time became 0.51 second. That makes sense? Go ahead and use this t here to figure out the value of theta will be pi divided by 6. When t equal 0.51, the value of theta dot will be negative 1.7. Please don't forget to use the radian system on your calculator. If you put t equal 0.51, the value of theta double dot will be negative 2.1. To summarize, your theta equal pi divided by 6. I think pi divided by 6 equal 0.52. Theta dot equal negative 1.7. Theta double dot equal negative 2.1. R equal 4. R dot equal 0. R double dot equal 0. I am ready. We are looking for the acceleration. Your acceleration has two components, AR and A theta. AR equal R double dot minus R theta dot square. If you go back to the summary, here you go. This is the value for the, this is the value of the radian component, R double dot minus R theta dot square. Go ahead and put your numbers. R double dot 0 minus R 4 times theta dot square negative 1.7 square. So your final value for AR will equal negative 11.6. A theta equal R theta double dot plus 2 R dot theta dot. If you go back to the summary, here you go. Here is the value of the transverse component of the acceleration, R theta double dot plus 2 R dot theta dot. Just to go ahead and put your numbers. R equal 4 theta double dot equal negative 2.1 plus 2 times R dot 0 times theta dot negative 1.7. So your value will be negative 8.4. Once you get the two components of the acceleration, this component and this component, so the final value of the acceleration equals square root for negative 11.6 square plus negative 8.4 square under square root equal 14.3 inch per second square. That makes sense? So this is the typical problem in this part of the module. I'm giving you expression for theta, I'm giving you value for R, then I figured out R dot, R double dot, theta double dot, and then find out the component of the acceleration. Any question? Let me do one more example on the same part. One more example. We have a slotted link is pinned at point O. If you see the mechanism of this slot, we can find out that this link will be rotated about point O. At the same time, the point B is will move inside this distance R. So whatever the mechanism of the problem, since we have R and the theta, that means we are talking about curvilinear motion in cylindrical components. You must have a key in the problem that guide you which part of the chapter, because so far for the curvilinear motion, we cover three parts: the X and Y component, the tangent and the normal component, and the cylindrical component R and the theta component. All of them talking about curvilinear, the motion in a curve. But we have different system of components, XY, which is called rectangular components, tangent and the normal component, cylindrical component R and the theta. That makes sense? So since the problem mentioned the theta and the radius, That means we are in a cylindrical component. So what is given? To solve this kind of problem, I do recommend to put your hand on what is the value of R, what is the value of theta, what is the value of R dot, what is the value of R double dot, what is the value of theta dot, what is the value of theta double dot, because without these values, you cannot solve anything. So the radius is given, 0.4 theta. If you differentiate this expression one more time with respect to time, it will be 0.4 theta dot, 0.4 theta double dot. I am trying to differentiate this expression with respect to time. Theta is given, yes, theta is given by divided by 3 radian. Here you go. Theta dot is given, yes, theta dot is given here, 3 radian per second. But it's given another information. This theta dot, which is called the angular velocity, is constant. If theta dot is constant, if you differentiate it one more time to get theta double dot will be 0. Why 0? Because the theta dot is constant. If you differentiate any constant value, will give you 0. Does that make sense? So if you put here theta equal pi divided by 3, the value of R will equal 0.42. Just move theta and put pi divided by 3. Just remove theta dot and put 3, so this value will be 1.2. Just remove theta double dot and put 0, this value will be 0. Now I have everything I need. Theta dot, theta double dot, this value, by the way, is pi divided by 3 equal 1.05. So for the velocity, let's start with the velocity. For the velocity, we are looking for VR and V theta. The value of VR equal R dot. The value of V theta equal R theta dot. If you go back to the summary, here you go. This is VR, R dot. This is V theta, R theta dot. So put your numbers. R dot equal 1.2. R equal 0.42. Theta dot means 3. So this value will be 1.26. So I found meter per second, meter per second. I found the two component of the velocity. If you can, if you would like, but it's not required. We are looking for radial and this transverse component. So keep them as it is. But if you would like to find out the final velocity, will equal square root for 1.2 squared plus 1.26 squared. For the acceleration, we have the radial component and the transverse component. Radial component equal R double dot minus R theta dot square. You have everything you need. R double dot is 0 minus R 0.42 times theta dot square, which is 3 square. So this value will equal negative 3.8. A theta equal R theta double dot plus 2 R dot theta dot. Put your values. R is 0.42, theta double dot 0 plus 2 R dot 1.2 theta dot 3. This value will be 7.2. So I found out the two component of the acceleration. Does that make sense? So this part of the module, just put your hand on these three values. R dot, R double dot, theta, theta dot, theta double dot. That makes sense? That makes sense? Anybody has any question? One of the question in your quiz is this one. So We have this mechanism to lift a weight. We have this weight hanging at point B, and we have all of these pulleys and this mechanism until you reach to point A, which is attached to this motor. Does that make sense? So we need to determine what is the constant speed at which the cable at A attached to this motor must be in order to hoist the weight at this box by 6 meter in 1.5 second. Keep in your mind, the weight velocity is 6 meter in 1.5 second. So velocity of the weight equals 6 meter divided by 1.5 second will equal 4 meter per second. This velocity of the weight is the same velocity of pulley B because this weight is already attached to B. Does that make sense? Your quiz will have a different value, but I'm talking about the same idea. I'm talking about the same idea. What is the idea behind this mechanism? I would like first to start. We must have a datum reference. This reference will be at the upper pulley. From this reference, I can measure out any distance. Second point, keep in your mind, we have this point A around this pulley and the point D around this pulley until you go up. This is one cable. This cable is not attached to any other cable. That makes sense? I'm talking about the blue one. So this distance, I will label it SA. This distance will be SD. And on the other side, we have another SD. So I can say SA plus 2 SD will equal the length of the blue cable. That makes sense? So distance SA plus SD, and we have another SD. If you add all of these distances together, it will equal the total length of the blue cable. Keep in your mind, this length of the blue cable is constant. No change. The length of the blue cable is constant. It will not be extended or shortened. But the position of cable D, the position of point A will be variable. So if you differentiate this equation, will tell you velocity at A plus 2 velocity at D will equal 0. And this is equation number 1. I just differentiate this S with respect to time. Remember, your velocity is S dot or first derivative of S with respect to time. So if you have S, just to go ahead and differentiate it will give you the velocity. S at A will give you velocity at A. 2S at D will give you 2S V at D. Differentiation of constant value will give you 0 because this length is constant. One more time. One more time. If you look to the red cable, we have this red cable. This red cable is hanging from D to C, then to the reference. So what is the length of this cable? I will label it L2. So anybody can tell me what is the length of this cable? I can say SC minus SD plus SC, because this distance equal SC. If you subtract SC minus SD, will give you this little part. That makes sense? And on the other side, we have SC. So SC minus SD give you this little part plus SC equal L2. If you simplify this expression, that means 2SC minus SD equal L2. The length of the red cable is constant. So if you differentiate, this expression will give you 2 velocity at C minus velocity at D will equal 0. And this is equation number 2. One more. If you look to the pink cable, we have another cable here, the third one. The length of this pink cable is constant, L3. This value is constant. What are the component of the pink cable? Keep in your mind this distance from the datum, from the reference, equal SB. So this little part from this side will equal SB minus SC. If you subtract SB minus SC will give you this little distance plus SB from the other side will give you the total length of this pink cable. If you simplify this expression, 2SB minus SC equal L3. If you differentiate this equation, will give you the third one, 2 velocity at B minus velocity at C equals 0 because this side is constant. And this is equation number 3. So I can say how many cables do you have will tell you how many equations I expect. Now keep in your mind the velocity at point B is given. Velocity at B, which is the velocity of the weight, is given by 4. If you put here VB equal 4, I can find out VC will equal 8. If you put VC here equal 8 from this equation, I can say VD will equal 16. If you put VD here 16, I can say VA will equal negative 32. Negative means VA must be downward, and that makes sense. If you would like to lift this weight up, you must move point A down by this motor. So the velocity, the required velocity for A must be 32 meter per second. Does that make sense?